Hello there. We are team two. I'm Vlad, and the rest of the team members are Gwyn, Summer, and Steve, and we're going to be talking about Visual Studio IntelliTest. So just as an overview, Visual Studio IntelliTest was created by Microsoft, and this Visual Studio IntelliTest was created for their Visual Studio Enterprise Edition. Later on in this presentation, we will include some discussion on the different use cases where the software may be useful, how to apply or use the software, and which features can be used effectively in development. So, what even is IntelliTest? So Visual Studio IntelliTest automatically generates unit test cases, and it's more specifically oriented for the .NET code and C# languages and frameworks. And how does it create these test cases? So it uses AI to see the project's context where then it can automatically write new test cases to comprehensively test the code while the code base is being developed. To continue on uh, IntelliTest, there are many benefits. IntelliTest saves lots of time for developers to develop their code rather than spending extra time trying to write test cases of in trying to make see how the code functions. And another thing is it also includes support that allows the user to define how to handle specific exceptions within test cases. Before we're going to get into some of the advantages and some of the other benefits, I would like to talk about some of the downsides of IntelliTest. So IntelliTest is only available within Visual Studio Enterprise Edition. So it's only one single IDE. And the other thing is the language that it supports is really only like C#, C, C++, and the .NET framework. But the caveat with the .NET framework is that it doesn't support .NET Core and some of the other .NET features that would have been really useful. And other thing is that there's no multi-threaded support. So whenever IntelliTest is going through your project and looking at the context, it does not know how to write test cases for programs that use multi-threading. It just cannot figure it out. And I am not sure if Microsoft is trying to develop that feature as well. Some more of the disadvantages or downsides is that IntelliTest may sometimes give you just incorrect test cases because IntelliTest it can misunderstand the actual intent of the code that was being written and why it was being written. And through that, it can give you test cases that don't exactly model what the developer truly wanted to test. Another thing is with code base size. If the code base or project is very large, sometimes IntelliTest has issues knowing the entire context of the project and can kind of fall back and struggle to keep up with the new project or the progress of the project and the different changes that have been made, and trying to rewrite all of that is just sometimes confusing for IntelliTest to fully figure out. But now on the flip side, there are some really good advantages. for IntelliTest. Some of these things are advanced warnings. So some of these advanced warnings are showing how different interfaces, functions, methods are using different parameters and how each of those parameters will be viewed within those different interfaces, methods, uh, or just subprograms. And that would allow the developer to have a much greater understanding of how the code runs and how is the code intended to actually function. Another feature that is really nice is that it's able to create tests outside of actual code execution. So IntelliTest, it allows you to create these parameterized unit tests without needing you to run the code. So when you're developing, you're not constantly needing to rerun everything, but it already has the capability to create these tests without needing to run anything. Some more advantages is, of course, uh, let's say even earlier, how I was saying the disadvantage would be that sometimes the test cases are not exactly what was meant, but still the biggest thing is that you would still be able to save lots of time writing test cases as you would already have a skeleton of a test case that should be pretty close to correct or just require minor modification, or it can even just be correct right away and save the developer lots of time so that they can actually focus developing on their actual on just programming rather than trying to write test cases. Now I kind of want to flip into just more of an introduction on how to integrate IntelliTest into your workflow. So, of course, IntelliTest would be used during development, and it is very easy to access. It is right there in the Visual Studio IDE, and you are able to right click on any of the methods or classes to see excerpts generated of just what the different pieces of code actually do, how it's supposed to function, and the tests as well. They're generated while the developer is coding so that they can maintain focus on the things that are more important in writing the different business logic. Another thing that is really cool is that you're just able to easily rerun IntelliTest while uh, you're developing, so it can automatically create these new test cases. And it can have it that if you already have a different file with manually written test cases, it can generate and place those alongside the other written tests or even within the file that has the other generated test cases. The other thing is that developers that are able to then, yeah, they're easily able to generate test cases to check if their coding is working as intended. Everything can be done actively instead of needing to wait until the end of the programming phase for the testing team to figure it out, as well as it just gives them really great insight on if the program is doing everything exactly how they want it to before the code has to be peer reviewed by other people and possibly needing changes to be made. Another thing that is very cool with IntelliTest is since you can right click on different methods and functions interfaces, that allows you to get really quick explanations of just the context of these different functions on how they're supposed to work, what type of parameters do they take, and is so that it will allow you to fully understand what is that part of the program really supposed to do. So with all of those in mind, there's a really easy process that you can follow. So when you're developing your project, you can, of course, start with developing your new business logic. So that's just all of your functions, methods, or subprograms that you're wanting to implement. Then what you're able to do is very easily, you can run IntelliTest. You get your test results back. And when you get those test results, you're either able to commit the code to source control, or that also gives you a great opportunity to fix any issues that you have possibly missed or other developers have possibly missed during development. Another thing then is you're able to add more additional assertions in different more important parts of the code to make sure that everything is functioning exactly how it was intended. And then after you do those additional assertions, you're able to save those written test cases within the different files uh, in your test case file so that everything's stored, everything's organized, easy to go back to. Uh, and then that just would make it so that development, you're able to focus on development rather than going back and looking at those test cases or spending too much time rewriting everything. Then after all of that's done, you're able to easily commit your changes to your source control. So then the different people, different team members are able to uh, look through your code, peer review it, make sure that you had fully understood uh, the requirements that were given to you so that they can validate everything so that everything as well is working how it should. And then you're able just to keep repeating this flow so that for every new feature, new subprogram, you can just have a very easy flow to focus on actually programming everything rather than uh, being stuck written in test cases or trying to figure out exactly how your program is supposed to run.
Now that we know what IntelliTest is at a high level, I'm going to go through its main features. I'll focus on what the tool actually does for us as developers. I'll walk through how IntelliTest generates tests, how it finds edge cases, how it uses insertions in coverage, and finally, how it keeps those tests up to date. The IntelliTest test maintenance and regeneration feature helps with maintenance and regeneration of our test cases. Tests are not a one-time thing. Our code can and will change, and tests can get out of date. When we refactor a method or change its behavior, we can rerun IntelliTest on that method. It will compare the new version of code with the existing generated test. Some tests still might be valid, some might need to be updated, and IntelliTest can add new test cases for new branches. If the behavior changes in a way that breaks the existing test, those tests will fail and basically tell us, hey, this used to return X, now it returns Y. Is this what you meant? This makes IntelliTest a good safety net when we're doing a risky change or refactoring because it can reveal accidental side effects that we didn't plan on. So instead of manually editing a bunch of tests every time we touch the code, we can lean on IntelliTest to help us keep our test suite in sync. Next feature is parameterized test. Instead of generating 50 separate methods that look almost the same, IntelliTest usually makes a single test method that takes parameters. IntelliTest provides different input combinations to that one test method. So you get a lot of coverage, but the test code is more compact and easier to manage. This matters when our code changes. If the method we're testing gets a new parameter or changes type, it's way easier to fix one parameterized test than 50 almost identical tests. So parameterized tests are IntelliTest ways of keeping generated tests from turning into a huge, unmanageable mess. The main takeaway is that this is IntelliTest's way of not just spamming a whole bunch of random tests, but it tries to organize them in a way that's more maintainable. The first big feature is automated test generation. This is really the main reason you'd use IntelliTest. Normally, writing a unit test is kind of repetitive. You'll write the same pattern over and over. Arrange the input, call the method, check the output. IntelliTest automates all of that. The workflow is simple. You pick a method you care about and run IntelliTest on it. IntelliTest analyzes the method, then creates a test project and a bunch of unit tests for you. So instead of having to sit there and think, okay, what if the input is 0? What if it's negative? What if it's huge? IntelliTest does all that thinking and generates the test. It's especially useful on existing code that doesn't have any test yet. For example, if you inherit a project from somebody, you can immediately spin up a unit test suite just by running IntelliTest on the important methods. The tests it creates are real, standard unit tests. We can open them, read them, edit them, and run them on a normal test runner. Another big feature is how IntelliTest explores different code paths and edge cases. When we run IntelliTest on a method, it doesn't just pick random input values. It actually looks at the logic, like an if statement, loops, or exceptions, and it tries to hit as many of those branches as it can. For example, if there is an if condition that checks for a negative number, IntelliTest will try a negative value. If it checks for null, it will try passing null. If there's a boundary like x is greater or equal to 100, it will try values around that boundary. This is where IntelliTest shines, because humans are pretty bad at thinking of every weird edge case. We usually test the norm values that we are expecting, and maybe one or two extremes. IntelliTest systematically looks for those edge cases. This feature helps increase the code coverage and also helps us catch bugs that we didn't even know were possible. Code coverage support is the next feature. With this feature, IntelliTest is able to show us what part of your code is covered. Once IntelliTest has generated tests, we can run them like normal unit tests. After they're run, Visual Studio lets us open the code coverage window. In that view, we can see which lines and branches of our code are covered by the IntelliTest generated test and which ones are still uncovered. This is really handy if your instructor or your team has a coverage goal, like we want at least 80% covered. Instead of guessing, you get a clear visual map of what's tested. If we see important parts of the method that are still uncovered, we have two main options. The first, rerun IntelliTest and let it explore more, or for the second, write a few manual tests ourselves to hit those specific cases. So IntelliTest, with its code coverage feature, gives us both quantity and visibility, a lot of these tests, and a clear idea of what they're actual testing. Another feature is auto insertion and exceptions. So basically, once an IntelliTest has decided which input to try, the next question is, what should it insert? Another nice feature is that it generates the insertions for you. On the first run, IntelliTest records what methods actually return for each input and what exceptions it throws. Then it writes an insertion statement that basically says, given this input, I've observed this output. For exception cases, it will mark that the method is expected to throw a certain exception. After that, those tests become a snapshot of the current behavior of the code. If you change the code and start running something different, those insertions will fail and it will tell you that something's changed. Of course, we're not stuck with whatever IntelliTest observes. We can go into those test codes and tweak the insertions to reflect what the correct behavior should be. But IntelliTest gives us a really nice, fast starting point. So to quickly recap the features we just talked about, IntelliTest automatically generates unit tests for our methods, which saves us a ton of time. It uses parameterized tests to keep the generated code compact and manageable. It explores different branches and edge cases, hitting a lot of scenarios we probably missed. It auto-generates insertions and expected exceptions, turning current behavior into repeatable tests. It integrates with our code coverage so we can see exactly what's tested. It helps with maintenance and regeneration when our code changes and catches regression. And it has a configuration option so we can control how many tests it creates and which part of the code it touched. Together, these features make IntelliTest a pretty powerful tool for quickly building up a test suite, especially on existing code bases for students who don't want to handwrite every single unit test. The last feature I'll mention is configuration and filters. On small methods, IntelliTest might only need a handful of tests, but on a much larger complex method, it can potentially create a lot of test cases. To stop that from getting out of hand, we can go into the IntelliTest settings. When we're in there, we can limit things like the maximum number of test cases it will generate for a single method, the time budget it spends on trying to explore all the paths, and which namespaces or methods to include and exclude. This is important for methods that interact with external sources like databases, files, or network calls. Those are usually hard to test automatically, so we might tell IntelliTest to skip or stub them out. By turning to those options, we can balance between getting a high coverage and keeping our generated test suite under control.
Hello everybody, my name is Gwyn and I am here to cover the use cases of IntelliTest. So, as we saw in Summer's portion of the project, IntelliTest is absolutely invaluable for any kind of team. It has some beautiful features that can be applied in many creative ways. I'm here to show you 3 specific use cases of IntelliTest, and then 3 kind of general, broad things that IntelliTest can do for your projects that can be applied at any phase of the life cycle. So our first one is faster testing with automatic test generation. So when you are doing quick prototyping early on in the development lifecycle, you generally just want to get core functionality out the door as quick as possible, so your project manager can see that it all is working with the customer. You don't want to spend a whole lot of time going, okay, well, what if I pass a null object to this? What if I try n+1 runs? What if I do all of this? You don't want to handle a whole bunch of tests for some basic core functionalities early on in development, but you want to make sure that it works and you're handling all of the edge cases. That's where IntelliTest is super useful. The ease of just right-clicking your method and clicking Run IntelliTest and being able to immediately have regression safety without a full test run is invaluable for refactoring that may follow this. Our second use case is reduced maintenance overhead. So testing has a lot of files involved. During this class, we really only did a couple test projects. But as you can imagine, as you start handling larger and larger code bases, the amount of tests required scales astronomically. So through the use of parameterized unit tests, or PUTs, developers only really need to maintain the logic of one test, not dozens of copies of that test. This saves a lot of time when you just really want to be focusing on developing your project and not maintaining the overhead of testing your project. On top of that, the third point, configuration. Configuration and filters allow the team to focus exploration time on only the most complex or risky parts of the code base. That method from 2 weeks ago that you've already tested extensively and you know the logic works, you can use those as the baseline. You don't need to go through and retest all of that every single time you want to test a specific method. Using configuration, you can make sure that you only test the methods that are valuable to you, that you're only focusing on the core functionalities of your program and what's currently being developed, rather than code that you developed a couple weeks ago that you don't need to worry about. Now, those are our 3 general uses. Those can be applied at pretty much any point in the life cycle, but here's some very nice uses that I have come up with. The first one is characterization testing. So this focuses on the problem of inheriting legacy code. Legacy code is extremely hard to handle even for experienced developers. It adds major technical debt to your projects, and it's just overall very intimidating. The core idea is that you should really refactor your legacy code, but as we can see from the code bases of large companies that have made it public, it's not that easy, or otherwise they would have already done it. That takes time and money that can be put forward to new projects, and if it's not broke, why fix it? There's many reasons to fix legacy code. However, a lot of companies aren't willing to put the time and money forth. IntelliTest tries to tackle this problem head on by making sure that companies don't have to invest nearly as much time. What you can do with IntelliTest is you can do what's called characterization testing. This focuses on capturing the character of your method. Any kind of issues it may have, anytime it doesn't handle a null reference, anytime it doesn't handle an off by 1 error in looping or something similar, it captures that logic, and then it generates unit tests based off of that logic. If you're running into an error that you don't really want to handle, because what if that error is being passed to a method 300 files away, and that is keeping the entire infrastructure of your Amazon web service up? You don't want to break that method. So, using characterization testing, you can automatically generate a regression test suite that makes sure that the functionality of your code is captured automatically. once you begin refactoring after that and tackling the issue of legacy code head on, if a refactor changes a test, so you know it should be returning a null pointer or something like that because you entered the wrong input. If that's the case, if the test doesn't receive a null pointer once you refactor, you know that you changed the core logic of the method that you're trying to refactor. So you know that you need to either revert it or try to fix that regression bug. Our second use case, or specific use case, is hidden edge case discovery. So the problem is that we as developers generally try to focus on one core path and then, a few obvious side paths that aren't meant to be handled. The main joke that comes into this is you walk into a bar and you order 1 beer. You order 2 beers, you order 0 beers, you order -1 beers, and so on and so forth. And then you send the bar to the customer. Now, when the customer receives the bar, they may go in and they may go, "Where's the bathroom at?" And then your bar catches on fire because you didn't even think to ask where the bar was, or where the bathroom was. So, what IntelliTest does is it does white box path exploration or smart fuzzing. It uses this absolutely amazing open source project called Z3 Solver. You can find it on GitHub, it's out there. But basically what the Z3 Solver does is it uses formal logic to try to determine every conceivable input needed to force code down every logical path. Being every single if-else statement, every single for loop, every single iteration of a for loop that results in an actual change. As we talked about in an entire unit of this class, that's a very tall order. So having a tool that automatically does that is absolutely invaluable for reducing software QA time. It can efficiently find very rare bugs like null reference exceptions that only occur in one specific nested condition or boundary issue that you may have just nonchalantly thrown into the code somewhere and said, yeah, that seems good enough. And so as we can see from here, it is from the output here, we can see that it is returning all of that stuff. So we have our first error is a null reference exception. An object was not set to an instance or, whatever that error is. So you would look at that and go, okay, so I'm not handling null references. I need to handle that. The next one is index out of range. So your method was provided a valid list, but the list was empty, and you didn't look at the assumption that the list needed to have an object in it. So you go and you handle that case, and then, it doesn't work when you're only provided one integer of 0. And so you go and handle that, and so on and so forth. It tells you what's valid or what, in the cases of 5, 6, and 7, what shouldn't be allowed, but is allowed. So 3 zeros, a 5, a 538, and a 0, a 67, a 0, and a 0. Those all shouldn't be allowed. They're invalid, but the method properly returns it. And now you can do what you want with this information. You can always choose, I like that bug, I think I'm going to keep it for whatever reason. But it does inform you about it, and it tries to logically find every way so you're not just brute forcing possibilities, which is beautiful for computation time, and it saves time, which is our core idea. And then our third and last one, it validates design contracts. So the problem is that in code or in business, you may be given specific rules. So, for example, if you're running a specific method, you know that the user is going to be logged in. It's the user cannot conceivably force that method to run without being logged in. So you don't need to check examples of when users are not logged in. That's when PEX assumes come in. So they set up valid preconditions for the engine to test with. So basically what this is, your PEX assumes are giving your engine a rule book that says, here is what is not on the table. For example, in soccer, you cannot pick the ball up with your hands. That is what PEX assumes are saying. If you create a method that plays soccer, you should tell it, hey, we're assuming you cannot pick up the ball with your hands. That's in the rule book. And so your engine is going to go, okay, I will not test anything that involves picking the ball up with my hands. And then at the end of the method, you will give it PEX asserts. Now, PEX asserts are what it is trying to break. So, for example, what if for our soccer analogy, what if the ball goes through a hole in the back of the net? Does that count as an error? That's what it's going to be testing with PEX asserts. It's going to be trying to find times that the PEX assert is not matching what you expect it to be. So for example, in this code, PEX assumes we're assuming that the array provided in the test add method is not null. And then we are adding an element to that list, and then we are making sure that the list contains an element. So what the engine's going to do, it's going to say, okay, I will not pass null lists. Doesn't say anything about about empty lists, about non-empty lists, about, whatever. It will make sure that there are no lists in that test that are not null, or that are null. For our PEX asserts, it's going to then go, okay, assuming we don't have a null list, how can we make it so that by the end of this method, the list does not contain anything, or does not contain that specific element? And that is what PEX assumes and PEX asserts are going to do. So, as said in our analogy, you may not want to test if a user is logged in, so you'll set your PEX assume to be is true, logged in, or something similar to that. And then your PEX assert will be something like this function executed correctly, so like the list contains an element. So I have been Gwyn. I will be handing off the last portion of this presentation to Steve, who will be handling our demonstration. Thank you all.
Hello everyone, my name is Steve Ward, and for this part of the presentation I will be demonstrating the IntelliTest, how to set up IntelliTest, which is actually relatively easy, how to use it in a real project, why it is considered a white box testing tool, and I will show how IntelliTest automatically generates unit tests for two of my methods, classes in C# that I'm using in Visual Studio. One is the arithmetic class that I have, and another is a Fibonacci class. Setting up IntelliTest is relatively simple. Before we run IntelliTest, the first steps you need to make sure is actually installed, which it comes packaged in Visual Studio Enterprise Edition. That is the only area you can have IntelliTest, and then you have to make sure that your C# project is using a is using a .NET framework. It's the only area it'll work in is .NET framework. As you can see here, my target framework is in the .NET. As we go on, setting it up for a solution is actually relatively easy. Start a project, make sure you are using a .NET. It has to have a solution with one or more classes. It needs methods containing logic that IntelliTest can analyze. It can't just be blank. In my project, I have a main method program, which is going to be calling my classes to run. Each of these classes compiles normally, and that is what all IntelliTest requires you to do. You do not manually add a test project or anything like that. IntelliTest will generate one for you, and it does it pretty automatically. So running IntelliTest is pretty easy as well. So I will make sure, as you can see, this is my buildable code, and it runs my Fibonacci class and does all my arithmetic methods that I got. We're gonna exit that. So to run a process, it's extremely simple. You're gonna open the file that you want to go to. For our instance, we're gonna probably start with arithmetic. You open the file, you go directly into the method body or the class name. You're gonna right click and then you will see the IntelliTest. So if I go over here to arithmetic, you'll see right below unit testing is IntelliTest. You can run specifically just the IntelliTest, or you can create a whole test suite for this. If I run it, it's gonna go through and build and run each possible method that I can. Well, the whole class will run just the class. If you click down here though and run a IntelliTest on just one specific method for add, it's gonna run and test to make sure you get the results you need. Fibonacci is probably a better one to start with. If you come over here and run IntelliTest, it's going to go through and check the logic for each line. So if we're trying to do a test project, we can go over here in IntelliTest and create IntelliTest unit. Now this is going to create a new project folder for us that runs test code. So as you see, it created a whole new folder for testing, and you come over here to the tests, you can see exactly what it's building. It's building methods that will go through and target each of your values and everything in it. It is strictly, in this sense, it is strictly white box testing tool because it analyzes the internal logic of our code. It reads your branches, the loops, your exception checks, and every condition in your C# methods or classes. Microsoft created something that generates test inputs that force your program to hit every possible execution path. Since IntelliTest depends on the internal structure of the code and not the requirements or user interaction, it is a white box testing tool by definition. And then as we come over here, I want to show you something. IntelliTest, run testing. Okay. So in my demo program, I have my arithmetic and Fibonacci class. These two classes are completely separate, and IntelliTest can test each of them individually. I also have a program CS file, which is just a simple execution of it, and IntelliTest ignores my main method entirely. It focuses on just the methods, the classes that have that need testing. So whenever I am demonstrating my Fibonacci class here, it goes through and tests each value here. My if, each one, it runs all the way through and checks each instance of this. Now let's see if this is gonna work again, because for some reason it's not building all the stuff. Okay, weird. Da, da, da. Oh, so let's go over here to divide because I have something in here. It'll also tell you the errors that you get, or if it doesn't work, for instance. See how I got a negative test here, and I got my error message: cannot divide by 0, divide exception. So, shoot. One of IntelliTest's strengths is his exceptional discovery that when IntelliTest finds a path that throws an exception, like dividing by 0, it automatically writes test methods containing assert throws exception. I don't have to write anything manually. This matches our group slide, the auto assertion and exceptions. Let's see if we can go in here to the divide folder and check this out. As you can see here, divide test throws divide 0 by exception. It created its own method. And divide test 0, divide test down here too as well. So let's go back to the Fibonacci. Right click, select run IntelliTest again. So we get N0 and a 1, valid small numbers. Negative numbers will throw an argument if I was accepting value, anything for N. If I modify either method, for example, adding a special case to Fibonacci or expanding the arithmetic logic, I can rerun IntelliTest and tell us update the parameters and create new cases for the pass and mark outdated cases. This demonstrates the test regeneration feature covered in our group slides. So if we come over here and say, we're going to create a IntelliTest unit for this one. See how I have a .1 now folder for just the Fibonacci's. You can do it for everything else. So now that I created this for this, so let's take an instance. I changed this to 12 instead of, or 13, or we'll do 10. Because I'm silly. Now, if I go down here and click, this isn't really changing much. Let's add a new, this will work. Run IntelliTest. It's gonna run, builds, and we get new results now because of this. This gives an extra, show the weakness, test regeneration code. If I modify either method, or for example, adding a special case of Fibonacci or expanding the arithmetic logic, I can rerun it, and new cases will, the past are marked outdated cases. As we can see, test regeneration here. As mentioned in our slides, IntelliTest saves developers times by automatically generating meaningful tests. As in white box testing, is very straightforward. It goes one for one. In this demo, I showed you how to IntelliTest is set up, which is really, it comes packaged in the Visual Studios. How you can run it is simple as just right clicking, going down to IntelliTest. You can create your own test suites from it, which it automatically generates the code for testing it itself. You could always go in and modify the test cases you need to as well. In this test, it 2 independent classes in a single program. How it finds exceptions and edge cases, how it regenerates test case when the code changes. And this ends the portion of my presentation.